we have used additional 1 kilonewton, and we use 3 kilonewton meter square for the live load section. And let us start our design by using this preliminary dimension. Let us start with 5 layers of CLT and 160 by 320 JLT beam. And then let us use this code for the timber design, and let us assume 700 millimeter as a rib-to-rib spacing, and the vibration part is checked based on the new Eurocode standard. And let us assume a rigid connection, mean that let us use first the structural adhesive, and we will double check on the flexible connection type. Now let us go to the software demo part. Okay. We have the same interface with TCC floor. We can navigate the detailing of the detailing as well. You know, we can see the orientation of the screw, the orientation of the CLT and the JLT part. We can see the distribution of the shear stress and the bending stress here, and we can see the 3D detailing as well. This is very important just to adjust our input. Now let us see the section definition. Here is the section definition for the CLT part. Currently, let us use the custom lab. As I mentioned earlier, our backend is ready just to include the product suppliers. But for now, let us use the custom lab. We can define the CLT lab in such a way, and we can select the material as for the rib part, and we can select a bunch of options for the grades for the JLT part. And let us use this default dimension for the rib. We can use a flexible and rigid connection, mean that if we use structural adhesive, we can select rigid connection type. But if you are interested to use a mechanical fastener, we can select the flexible connection. For now, let us use the rigid part. As I mentioned in our preliminary design example, let us use 70 millimeter rib distance. For the detail, we can find our educational content. This is the board length, 150, and then this is the design code, and this is the analytical method. We can change this to flexible, and we will have extended and gamma method. But for the rigid part, it's only allowed the shear analogy method. We can include or exclude the contribution of cross-layer stiffness. This is the behavior. Okay, this is our more information content. This is the given reference, and this is the behavior of the stress when we exclude and include the contribution of the cross layer. The first one mean that this one and this one is just the stress distribution when we include the cross layer, and this is the behavior of the section when we exclude the contribution of the cross layer. And then we can include or exclude the national annex part here. We already covered this section. And then we can use the default as well as the manual and input force load combination. And we can use different design equation, that is 6.10 and 6.10a and b. And let us use an intermediate floor, and let us define the loading here. Let us use this dimension, what's given in our preliminary design example, and this is the same load definition with the TCC part. And this is the limit for the deflection. And now let us see the vibration part. Let us use the same vibration method with the TCC floor system. That is the revised Eurocode. We can find the details here. Now finally we will have output summary, the deflection requirement, the vibration, and the shear and bending. But when we change the connection type from rigid to flexible, as you can see here, the deflection is around 24.71. But if you change the connection type to flexible, mean that a mechanical fastener. Let us keep all the inputs similar, but let us define the connection geometry here. Let us use vertical screw, but we have the option to use inclined one. But for this preliminary design example, let us use the vertical one, and we have the option to select screw suppliers here. So let us use the Eurotech for now, and we can define family of the screw here, and we can select the screw type, and we can use filtering based on partially or fully threaded part. And here is the screw geometry definition. Let us use the default part. As you can see here, the deformation is higher now. That is almost 44.95. The previous one is 22.71, which means that when we use a semi-rigid connection, the deformation is increased, but when we use rigid one, the deformation will be decreased. So let us change to rigid one and see the possibility of this floor system with 9 meter span length. So let us change the span length from 7.5 to the 9 meter. Keep all the rest as it is. As you can see here, our ribbed deck can support a 9 meter span length as well, even if the deflection as well as the other utilization is increased. So we can allow up to 9 and more span lengths in this ribbed deck floor system. This is all about the advanced floor system webinar section. That is all about. Thank you.